Hi, everyone. I'm Julio. First of all, thank you for attending the talk. The talk today is named FloorPlan, Visualize Databases Evolution. My name is Julio, as I said. I work at SoundCloud already for around 4 years here in Berlin. And we're going to go through a bit of the history of like the SoundCloud Android code base, since this is an Android conference, of course. I'm going to talk a bit about how we organize our documentation, and also then for the bulk of this presentation, I'm going to go over how we've built this tool to help visualize some of our database schemas that we call FloorPlan. So let's get started. Before we go into the tool, of course, as I mentioned, I want to describe a little bit about SoundCloud and the environment with our engineering team as well. So if you don't know what SoundCloud is an audio streaming platform. We have more than 200 million tracks. And that includes, of course, songs and music in general, but also includes vignettes, includes recordings, includes also many DJ sets, and that's what SoundCloud is most famous for. We welcome more than 25 million creators that upload tracks to our platform every day. And the platform is available for streaming in more than 190 countries, like reaching 200 countries in the world. 90% of that usage comes from mobile devices. So that means Android and iOS. As you would expect, most of the paying users are on iOS, but most of the users overall are Android. So for us, the Android engineering team, that's kind of like quite a big responsibility as well. Specifically about like the tech stack of SoundCloud and how the history unrolled. It started like more than 10 years ago as a Rails application, this single app written in Ruby and with a MySQL database behind. But since then, of course, we've done like a lot of work to make it more scalable, more secure, and so on, and also to have like a safer and saner tech architecture. So this monolith also we've extracted a lot of microservices. We created like API gateways for our clients to talk through, and since the beginning, of course, we introduce more clients. So not only the website, but the Android iOS apps, and then other apps that also integrate with our backend. By now, we are like dozens of engineers, hundreds of services running in production, serving millions of requests every day. And with the microservice architecture, kind of like our organization also changed in how we set up the teams and also the tooling. And with the microservices, we kind of moved into more of a polyglot development setup. So each team has the opportunity to choose whatever stack makes more sense for their work. Whether that's like the programming language they pick, or the testing tools they want to use, or the CI frameworks, or whatever, right? Today, the reality is that kind of as time passed, we converged into a similar stack, more or less, because of how tooling got developed and how like more acquainted we got with given technologies and the support that we got from the infrastructure teams as well. So most of our services today are written in Scala in the backend or Go, but we also have like some services written in Java. And as I mentioned before, our main monolith is still in Ruby. And we run like different types of database technologies as well, MySQL being the main one. But of course, we have SQLite in the mobile applications, but we also have Cassandra and other types of technologies, depending on where you're sitting in the system architecture, for sure. Focusing more on Android now, the Android collective, as we call it, or the Android engineering group, is formed by around 20 engineers nowadays. Most of us sit in Berlin. I guess during this last year, we're more like remote and from the home office, but most of us are based here in Berlin. It's a single repo, it's a monorepo. It's a highly modularized code base. As you can see here from the data, we have like more than 200 modules, more than 8,000 tests that run, every day on every PR, which are like, last I checked, I think maybe a month ago, was like around 60 PRs per week that we get merged every day into the code base. So it's a rather fast-paced, rather fast-moving environment, and they are backed by around 15 databases. So just in our Android code base, we have like 15 different databases. And by database, I mean like database files, right? With multiple tables and relationships and even more entities and so on and so forth. And you know, queries flying around all over the place. So you can imagine that, you know, it's a not a small scale, like the kind of work we do, the responsibility also to make sure we ship like a build that works and with no bugs and high quality. But you know, like as a big team, that also brings like new challenges. And as I said, so many moving pieces and moving parts, it gets like a little bit trickier to onboard engineers and to make sure everyone is on the same page. So I'm gonna focus more now into like the database aspect of things within our application and go through a little bit of the history of how we organize our databases within the Android application, the Android app of SoundCloud, through kind of like a timeline, right? So as a disclaimer here, I want to tell you, like, take a look at this timeline kind of like as we were adopting the technologies, right? That doesn't mean we lived only with one of them at a given point in time. We mostly lived with two or even three of them at the same time, but basically how we adopted them. So, you know, when we started the Android application back in 2009 or 2010, you know, the Android framework was like still a baby, and we relied a lot on like bare SQL for our queries. So for those of you who are there for like a long time now, you probably remember the Open Helper APIs and how we were doing select directly from the Java code. And that's how it started as well. But as we developed the application, we felt the need for some extra features and some extra power, I guess, that the bare SQL APIs didn't give us. Namely, and more importantly, because we started since very early on using RxJava. In fact, like SoundCloud, I think, was one of the first engineering groups that picked RxJava to like architect their app. I think like still in 2011 or so. Our code was very like based on observability, right? So, and this reactive paradigm and the reactive mindset, basically, so that something changes in your data source and then your UI reacts to that and updates the screen accordingly. So the SQL APIs didn't really give us that feature, and for that reason, we started developing internally a library that kind of wrapped the SQL APIs to provide that observability factor, right? We call the library Propeller. Of course, the library, you know, being developed internally, we also added some other interesting features for us, like it had a linear API. At the time, we thought, you know, this is an API that makes more sense for the SoundCloud use case, but also introduced some other benefits, like for instance, some type safety, right? So instead of like reading bare SQL code, it would return as already like the unmarshaled models, right? Like the data models for the presenters to deal with and so on. You know, our goal with Propeller was that at some point we wanted to open source it as well. Like the community could for sure benefit from something like Propeller. At the same time, or less at the same time as we were like building Propeller, of course, other companies also faced the same challenges. So they also started building their own solutions. And as we were preparing to open source Propeller, Square open source SQLite, which became you know, very widespread, and it's an amazing library, not only because it gave what we wanted with the features, you know, the type safety features and the observability, but extra features on top. So SQLite is highly based on code generation, right? So you write your models and then it generates in runtime, but it also separated SQL and Java completely. And more recently, even they added the multi-platform feature of it, like the multi-platform aspect. So, you know, as we looked into SQLite and our implementation with Propeller, we figured maybe we should move into that direction instead of trying to come up with something that will compete or maybe cannibalize users from each other. And the fact that SQLite was already open source and had already kind of like a movement in the community also gave us the benefit of like making it easy to onboard people who were outside of SoundCloud. So we started migrating some of our databases into SQLite from the Propeller infrastructure up to a point where we had like them sitting side by side in teams. Of course, you know, with a modularized architecture, teams can decide which tool to use based on their needs. More recently, I guess in the last like few years with the architectural components, Google released also Room, which is kind of like the de facto solution for Android development these days, I guess. and it's really well documented. And you have like plenty of, Googlers, developer advocates going to conferences, writing articles and talking about it. So we of course took a look with like very much care into Room and the APIs that it exposed because it also made sense for us with the integration with RX Java. At the time, we're already in RX Java 2 and now in RX Java 3, but also kind of looking forward to the future with Kotlin and coroutines and flow and so on. It kind of gave us also like, okay, this might be also a path we want to explore. So this is more or less where we are today. In our code base, we have a mixture of SQLite and Room. We moved away from Propeller completely and completely sunset Propeller within the code base. And the teams are picking from both of them, right? We're building tooling on top of both of them. But basically the idea is that, when you start writing your feature code or your new feature, if you think that's going to be like more fitting into multi-platform, you might want to reuse some of that code with iOS or with Kotlin multi-platform in general. You might want to pick the SQLite route. Otherwise, people prefer to go into the Room route. So out of our 15 databases now, I think 80% or 90% of them are using Room, and the other part is on SQLite. The main benefit of that is, as I mentioned before, is like the high onboardability of the solutions, right? Like by having Propeller, even though we had full control over how the API developed, that also meant the maintenance burden, right? Of course, you want to add new features, you want to make it modern. So for instance, if we were to integrate Propeller with the coroutines API, for instance, or like, make the next level in its evolution, we had to do that ourselves. But not only that, the open source solutions, as I mentioned, are already widespread and known by the community outside. So when we onboard a new engineer into the team or when we hire someone, that is also a very important factor. And actually a KPI for us is how much time this person will join the team and will be able to add their first contribution, right? To open their first PR into our code base. And, by using common third-party solutions that are well battle tested, we can hire engineers that already know how to deal with these technologies, and basically that saves us from the training time and the training period, and they can be productive since day one. Okay, so we have, you have RX Java, you have the architecture, you're onboarding engineers every other week pretty much. There's like a lot of code to look into, a lot of databases to understand, and the data model starts to make sense in your mind, but it takes a while until you put all of that together, right? So this picture here is kind of like what I felt when I first joined SoundCloud. Is like, oh my God, there's so much I need to look into and so much code to read. And that's why I want to make a break into the topic of databases and discuss a little bit more about documentation, right? And how we document our code base, how we document not only our code, but also our practices to make sure that new engineers can join the team and be productive, as I mentioned. So let's dive into documentation for a bit. Here you can see more or less how we organize our repository. As you can see here, it's called Android Listeners. It's our listeners app. And you can see there we have many of the directories for the code, for the different modules in the code base. But here I highlight the docs directory. And that's because I wanted to mention that we, at SoundCloud, we want to make sure that we keep our documentation very close to the code that they refer to, right? Of course, our processes and the ways of working of the teams, they are documented somewhere else because each team has their own space. In our internal network, there's a website where people can navigate around. But with regards to code, we like to keep the documentation for the code really close to the source files. And, usually that can be done as code comments, for instance, documenting like units of the code, so methods or maybe classes or maybe even like specific lines if they're like a little bit confusing or misleading or whatnot. But when you want to describe overarching topics like architecture or how to do this type of thing or that type of thing, for instance, testing or CI and CD or whatever, right? Like these overlapping practices, we like to keep them as well very close to the code. So here you can see on our repository, we have this docs directory. And by having it close to the code, we get the power of Git as well with it, right? And the versioning platform, basically. So, and that's like the main benefit of it as well, is that, when an engineer introduces a change to that given architecture or to that given practice, they can also, in the same pull request, issue a change to the documentation file that is associated to it, in a similar way how code comments would be, right? And that gives us, by leveraging Git and of course GitHub here, we get some extra power exactly because we can leverage, for instance, things like pull request reviews, right? So, for instance, if an engineer changes a bit of the code base that is owned by another team and also changes the documentation they own, they might get pinged to review the documentation and check if that makes sense. Or maybe if they forgot to change the documentation, the owning team will be pinged because they changed code, and they can then refer them, please update the documentation as well. And something that is also very interesting is the atomicity side of things as well, especially when you think of Git as kind of like a tree of changes, right? And the code base is a very, very fast moving piece of software. It's very common that we will ship a commit and then we need to revert it, for instance, or maybe we're going to like move it between branches and or not. And with our documentation, the same is going to happen. So by having the documentation in the code base, we don't have the problem of someone changing the docs, maybe reverting the commit of the code later on and forgetting to unchange the documentation, right? Everything is atomic, everything happens at the same place, and it is distributed as well through the Git system. So everyone has the most up-to-date documentation that also works offline, right? So in case of an outage, for example, with our infrastructure, there is no problem of like, oh my God, I need to access the website to check how to run this command. And the website is offline as well. Everyone has a copy of the documentation locally that they can access from wherever they are. So another interesting benefit, and like now moving more into the tools realm of the documentation, is by having it within the code, we can also do some interesting things, like for instance, processing it, right? So, in our documentation directory here, we have basically a tree of markdown files that we keep in the code base, and we run these markdown files through this tool called mkdocs that I could not recommend enough. Like it's a really interesting tool if you're interested in like setting up a documentation website. How mkdocs works basically is that it takes the markdown files that you have in your system and then generates HTML out of it. So basically you can build a website out of the markdown files. So the way it works for us at SoundCloud is that we have it integrated in our CI pipeline. So every time we merge a new commit to our main branch or to the master branch, this website is going to be rebuilt, and then we have up-to-date documentation online, right? We deployed that website to our internal network within SoundCloud, so all of the engineers can access that through their computer. But not only the engineers, which is also an interesting benefit. Engineers outside of the Android group can do that as well, and PMs can also do that. EMs can also do that, and our designers can also do that. So they don't need to check out the entire code base, which is a rather heavy code base. They don't need to know how to deal with Git. They don't need to know how to deal with Gradle, or they don't need to know how to deal with mkdocs even, right? It's just a point-and-click experience through the website. So here you can see how it looks. It's like just a screenshot of how our website is organized and is set up. And we use a theme called Material, using basically the Material design scheme on top of our mkdocs distribution deployment. And you can see here how it's organized basically, right? Like this is what you can see here is like the architecture is just a markdown file that we have somewhere in our docs directory, but it can also be organized within sections. So you can see on top that we have an onboarding section for new joiners. We have a CI section, a getting started, how to do releasing, testing, and so on. And then within the architecture section, we have subdirectories as well. One of them, as you can see there, is the databases, or another one for deep links, where we list all of our deep links. And then other general documentation about libraries, modularization, and so on and so forth. So, as I mentioned before, this website is deployed on our internal network within SoundCloud or internal VPN. But the files are actually in disk, right, in every engineer's computer. So as I mentioned, it's not that you absolutely have to go through the website. If you need access to the files, you can check out the repo as well. So now I want to do a quick break of talking about like how we host and how we deploy things, to also mention a bit of like theory behind, and also not even theory, but like, just how we are pragmatic with our documentation as well, right? So here I want to bring this quote from Eric Evans in the domain-driven design um, um, space. And he says that a document shouldn't try to do what the code already does well. And I think that's interesting for our discussion here, because, and how I translate that is, you don't want to document things that are already written in code, right? And not only that, if you can make your code document itself, then you should do that, right? Because code changes, documentation changes as well. And most of the time, one changes without another changing. And then documentation can rot just like code can rot. So you want to make sure you keep both of them as close as possible, right? So your code effectively should be the source of truth for your documentation. And that's where we got our heads basically like scratching our heads, is like, how can we prevent people from forgetting to update the documentation, right? Like, even though we have the documentation in Markdown files, even though they're going to be reviewed by pull request, we need the human interaction to say, hey, you open a pull request in the piece of code that I own, please don't forget to update the documentation, and here's a file for it. Instead, we want to automate that process. So looking specifically at our databases here, how can we make that happen, right? Like we're missing this piece in between. How can I translate the code that actually describes how the database is architectured and translate that into some sort of like human readable piece of text, or in this case, an ER, entity relationship diagram, so that people can just look at them and like understand how's the setup. So that's where FloorPlan comes in, right? Like that's the tool we've built internally and open sourced, and the tool that I want to describe next. And that's the tool that basically performs this automation, pulling the schemas from the database and translating them into diagrams. So let's go deeper into FloorPlan and go more or less into its architecture as well. So FloorPlan is organized as a pipeline of components. You can see this as kind of like a factory construction, let's say, right? Like each component receives the input of the output of the previous component, and then passes that down into the line. So we start with a database schema, whatever that is. Like we start with a file basically that describes how the schema looks like. And then we have this box that we call a consumer that is going to translate that schema, perform some magic and like process that file to translate that schema into a DBML file. We're going to go deeper into what each of these boxes are, but here DBML is basically an intermediate representation of that schema before it gets translated into a diagram, basically. And that's the end goal of our pipeline, right? Like to have a diagram that describes how that database schema and that organization looks like. So the consumer, looking at the consumer box, this is the way we built this. It's kind of like, it looks like it's a fixed pipeline, but in reality, we use a lot of like dependency substitution here. We rely on interfaces basically on each of the steps of the pipeline to allow for extensibility, right? So this consumer box is actually an interface, and then we can have multiple different implementations that match whatever schema you want to consume, basically. So for instance, when we look into Room, Room exposes, there is a mechanism to expose Room schemas as JSON files. So here I just copied this slide from the official Room documentation. You can define an argument schema, it's called schema location, into your Gradle configuration for Room. And every time you build your database, Room is going to spit out the JSON file at compile time, right? That JSON file is intended to be used for testing purposes, right? So you can compare version 1 with version 2 and then assert that the right things changed. But here we kind of hack into the system in a way to also use the JSON file as an input for FloorPlan and to generate the entity relationship diagrams. So here you have an example. I took made a GIF out of the scheme of TV. TV is this app that's developed by Chris Baines in the open, and basically it's kind of like a TV series and movies tracking app. But you can see that the JSON schema can get pretty long and pretty complicated, right? Even though it's JSON, for sure it's readable by an engineer, you still need to understand what JSON is and like how the table are organized and go through each of the properties. So if I ask you, for instance, how many of the properties in this database are null, that's going to take you some time, basically, to go through the entire schema and understand. And as the schemas grow, you can imagine that this JSON file gets pretty large. Anyways, we take this JSON file and we wrote a consumer for it, like basically an implementation for that interface that deserializes that JSON file into a DBML representation, right? This is just one example of a consumer we could write, basically parsing the JSON file. But within SoundCloud, as I mentioned, we also use SQLite, and SQLite doesn't expose these JSON files. So instead, what we did is we wrote a consumer that receives the database dump directly, the DB file from the SQLite database, and uses queries basically to rebuild that schema. So using a JDBC driver, we basically connect to that database and perform queries to rebuild it, right? And that's how this consumer is set up, right? So as you can see here, it makes FloorPlan, the overall pipeline, kind of like agnostic to where the schema comes from or even how the schema is organized. You can, as long as you have a consumer that can translate that into DBML, the rest of the pipeline doesn't need to change. So yeah, let's move now into the next block of the pipeline, and that's specifically DBML. DBML is a language, is a DSL language that is also open source to define and document how database schemas work. So one could say, well, why don't you use like just bare bones SQL for that, or in our case on Android like SQLite or Realm for that? And that's because it's not really like easy to read, right? Especially if you're not an engineer, and that's what we want to do with FloorPlan here, is to make the documentation accessible. You need to kind of know what SQL is, and you need to understand what a foreign key is, for instance, to understand relationships and so on and so forth. So the BML, on the other hand, is designed to be very simple and consistent, but most importantly, highly readable, right? So the goal of the language here is that you can, just by looking at it, understand, have a mental image of how that maps into the database organization. So here I have an example of what a DBML file would look like, or a DBML schema would look like. And very quickly, by looking at this file, you can understand that we have two tables with one reference between the tables and which ones are the fields of each of the tables, right? So there's no create table statement here. There's no foreign keys. It's easier. It's also like simpler, and you have like basically less bloat around how this is organized to represent the database. So the last bit of the pipeline is finally the rendering component, and that's what's going to then translate the DBML file that we parsed into a diagram, right? So if you remember, we're going to start with the consumer component, pass that into the DBML parser that's going to put that in memory, and then generate a diagram out of it. And here we rely a lot on GraphViz, and GraphViz is another open source tool. And as you can see, FloorPlan is built on top of like shoulders of giants, right? Like they're built on top completely on open source technology. And GraphViz is not even a Java tool, but it has Java bindings through a library here that I link, GraphViz Java. And basically what it is, it's kind of like a cyclic graph rendering tool, right? And you can draw pretty complicated graphs like the one you can see on the left, but you can also draw class diagrams and all sorts of other different graphs using this tool, and that's what we use here for FloorPlan as well, and the ER diagrams. And by using these Java bindings, we also enable, of course, Kotlin interoperability because of the already existing Kotlin Java interop. So here on the bottom, I put an example of how GraphViz would work, a simplified example, right, within FloorPlan. So basically, we instantiate a graph and then map the tables to nodes in the graph, and then references to links in the graph, and then finally render that in whatever format we want. So the format we picked at SoundCloud for our databases and for storing our database is SVG, but with FloorPlan and through GraphViz, you can export PNG files, for instance. You can also export the GraphViz specific format, which is called a dot file. but I guess it like graphics is also extensible to export whatever kind of format you're interested in if you write as well, like, plug in basically for it. SVG is specifically interesting for us, and I want to give like kind of like a spotlight for SVG because SVG, as you might know, SVG is just kind of like a XML on steroids kind of thing to draw vector graphics. And that is great because, as I mentioned, by being a vector, you can take any dimension, right? So you can scale it without losing quality. And that also means that when we check in these files into our code base, they have very little space. They take very little space, right? They're very light. But not only that, SVG allows for next level interaction, right, with metadata, basically. So by having some of the SVG nodes representing things that get rendered to the screen, we also can attach metadata to these nodes to define how interaction can work with the user, right? So making this example more concrete here, we can define things like how does a table react when the user is hovering over it with the mouse, right? So that's quite interesting because as I mentioned before, we host these files on a website. So our users are interacting with it through this kind of like web environment, and things like hovering over on dragging and dropping and so on, they are available, right? So here I put an example of how we use tooltips in the tables to show things like, for example, nodes or table aliases, right? So for instance, we have here this users table, and in the query, in the definition of the schema, that table has an alias called U for users, right? And here you can discover that alias by hovering over it, and that leverages the metadata that is attached through the SVG file. So, okay, so this is basically how we organize the files and how we organize our code base. But I also want to talk about the workflow, right? Because it's not only, you don't really drop a tool like that into a team and say, yeah, now you deal with it. For sure, you want to make it integrated as engineers day to day, and make it easier for them to use it as well without disrupting their already existing workflow. So, starting here, how we integrate FloorPlan into our existing workflow is how it's distributed, right? So FloorPlan is distributed in a few different ways. The first of them is through a CLI, as you can see here, a command line interface that people can install on their machines. But also, interestingly, we can install in our CI boxes, right? In our continuous integration workers, basically. And that's where things get interesting because we can allow for some automation, right? So as I mentioned before, we might generate these diagrams as part of as soon as a commit is merged into our main branch. So the CLI is one of the interfaces people can interact with FloorPlan. But being Android engineers, we rely a lot on Gradle. So FloorPlan is also distributed as a Gradle plugin, and that's actually how most of the use cases for FloorPlan are these days. So basically, the way it works is you apply this Gradle plugin into your setup, and then you can specify some of the properties like schema location, where the output's going to be set, and which format you're interested in, if you want SVG, PNG, or whatever. And then you can run a Gradle task. Basically, we generate this Gradle task called generate FloorPlan that runs the pipeline and then translates the schemas into the ER diagrams. Here I want to make like a quick parenthesis for sharing kind of like a pro tip of our setup. Given the scale of our code base, we started getting many plugins and also like many different ways of doing the same thing. So we figured, different teams might decide to store their schemas in a different directory, or they might decide to use a different format, for instance, for the ER output. And of course, we want to standardize things as much as we can to enable further automation. So one of the things that we've done is to wrap the plugin within another plugin. So here on the left side, you can see in this left box, we wrote this plugin called Room Support. Basically, that applies the FloorPlan plugin and already defines kind of like the properties that you want. It also, kind of uses the assumption that, if you're applying this plugin, you want to use Room as well. So we already include some dependencies. And that means that when you're actually writing feature code, as a feature developer, all you need to do is then apply that room support Gradle file to your Gradle script, which is what you see on the right side of the slide. And then you don't need to worry about specifying that these blocks over and over again, right? So by doing that, we keep our feature modules, like the Gradle files for the feature modules, really, really lean, really, really simple. But also we encapsulate all of the configuration that is related to room, exporting the schemas, or related to FloorPlan, for example, to ingest these schemas and standardize where things are going to sit, right? Where the schemas are going to be put on and where the diagrams are going to be generated. On top of that, as an extra, kind of like a bonus for our engineers, we also developed, in the infrastructure team, we also developed an IntelliJ plugin that kind of works, of course, with IntelliJ IDEA, but also works with Android Studio to kind of bubble up these diagrams, right? And make people aware that they even exist. So a very common use case is that an engineer from one feature team is browsing through source files from a feature that is not owned by his or her team. And they might go through the database schema. So we figure, this is a good opportunity to make them aware that we have diagrams for these schemas as well, for these databases as well. So here, what you look at is, I basically checked out the DuckDuckGo open source app and integrated FloorPlan into it. And you can see that when they define the database, we get this like little gutter icon that is also called a line marker icon that represents, okay, this database has schemas associated to it, right? And then by clicking on that icon, you get a list of all the files that represent this database with all the versions, right? So here you can see, version 1 to version 20 of that evolution of the database. So not only how the database looks like in the current Git head, like the commit that you're sitting on your branch, but also all of the previous versions of the database, so that you can kind of build a timeline of the history of that database, right? This field came before that field, or this field was this type and changed into that type later on, and so on and so forth. So by having the standardization that I mentioned before with within like our many feature modules, we can also sit on that assumption to automate even further our workflow, right? So as I mentioned, we deploy these files into our website. And since we know that they're all going to be sitting on a similar name directory, here in this example, I say FloorPlan output, we can write a script, for instance, that aggregates all these files and puts them into a file system structure that mkdocs can basically read and ingest, right, and serve. So this is basically what we're doing here with what this slide wants to like represent, is that our CI box does that. That's what it basically does, right? It runs FloorPlan on the commit that you just ship to the master branch, and then runs that script to aggregate them together and serve them through the website. So finally, this is how it looks, right? So this is the website, as I mentioned before, and as I showed before, this is how one of our databases looks. As you can see here on the left side, you look at the distribution of like all of the databases within the repository, and then you can navigate for each of the databases through the different versions, through the history of that database. So here, this example, I picked this, what we call the collections database. Basically, it's a database where you store your likes and your collection. And here we only generated version 4 and 5. And that's interesting, also an interesting topic to mention, because FloorPlan got introduced into the code base after this database already existed, right? And that doesn't prevent us from generating diagrams for it as well. That's not disruptive for the workflow. It's actually an addition to the workflow, right? You can still check out an old commit from, let's say, collections database version 1 or 2, generate FloorPlan, and then check in that SVG file, the diagram file, back into the repository, and that still will show up in the website because of how the scripts are organized and everything. So here you can see, by being on the website, it makes it really accessible, and it kind of democratizes access to the database schemas. You don't really need to be an engineer, or you don't, even if you are an engineer, you don't need to have the SoundCloud Android app checked out into your laptop or your computer to be able to see how the schemas look like. This is especially interesting for instance, our security team, who is doing like constant audits on how our data structure is organized, but also, engineering managers or other engineers in different teams who just, for instance, our backend teams who want to look into the Android app and see, is this field that my API is delivering persisted or not? Do I need to worry about backwards compatibility, or the data format, can I change it, and is that going to break an old version of the Android app that is already shipped maybe 2 years ago? They can do that by looking at the website and through the ER diagrams. Another interesting output of the pipeline is, we don't only generate, of course, the ER diagrams, but we can also choose to output the DBML files themselves. And as I mentioned before, relying on the fact that the DBML is very readable, highly readable, it allows from other interesting applications. So here what I'm doing is I'm running a diff, just a regular diff, between the two versions of the PlayQ database, so version 4 and 5. And since the BML is like, you have like kind of stable representation for the database, you can compare two versions and see what's different between them, right? So very easily you can see that one migration from version 4 to 5 changed the type of, actually removed two fields and changed the type of this source field from being nullable to being not null. And it's way easier than going through the JSON files that Ruby generates, for example, or to going even through the queries to understand what that migration is doing. We kind of sit on top of that and even go further, right? Because since engineers send pull requests and we have everything already in kind of like our Git space, we can integrate that with GitHub as well. So not only locally you can generate these diffs, but our CI can also generate these diffs. And then we can add these like GitHub comments directly to the pull requests. And that makes it easier for engineers who are reviewing the code, that they don't even need to check out the branch to see what's actually changing on the database definitions, right? Like just by skimming through the GitHub PR page, you can see that this PR changed the schema of this database, and that might affect something else. So, okay, wrapping up now, I think we covered a lot of ground. We covered, how we do documentation at SoundCloud, the history of the code base. We covered FloorPlan and also the workflow. So I want to wrap it up before we can open for questions. So, important topics of what you need to take from the talk basically is that we advise that source code should be the source for your documentation, exactly because you don't want your documentation to rot, right? Just similar to like commented out code, you don't want to have documentation that is not aligned with the source of truth, with the source files, because I personally feel like that it's better not to have documentation than to have bad documentation or documentation that is misleading, right? Because that can actually cause harm. With FloorPlan, we also integrated a new tool within the workflow with no disruption at all through automating the entire path for the engineers, right? So if you can look back into what I described, the workflow of the engineers, they didn't need to change at all, right? They still are writing their databases, they're still writing their feature code, but there's no new button they need to click, there's no new command they need to run to generate the ER diagrams or to host them on the website or even to add a comment on the GitHub pull request. Everything exists and runs through automation, so their workflow remains intact and it's not disrupted. Also, we generate value on every single step of the pipeline, right? So by parsing the schema into the BML, you get value by getting the BML representation and performing these diffs, for instance, or the diagrams and the final rendering step of the pipeline, you also get the diagrams. And then the final deployment into a website, you get even more value by democratizing that access to the entire company. Not only that, we augment the workflow, right? By tools like, for instance, the IDE plugin. Engineers who want to dig into the databases, now they have a new tool for discoverability, right? Just by navigating around, maybe you know how a database was organized in the past. We actually augmented it by providing a view into the entire history of how databases evolved within the code base and giving you access to it with a single click through the IDE. Not only that, we also enable potential extension, right? So as I mentioned, the pipeline is built mostly from interfaces and from abstractions, and we could, by being open source, of course, if you have a custom format within your company or you use something else another different type of database, you can still use the power of FloorPlan by relying on the individual steps of the pipeline. So an interesting thing we are exploring in the last few months at SoundCloud is using FloorPlan not only for Android code bases, but also for backend and iOS code bases. And as I mentioned, for instance, on the backend, we use MySQL. So within SoundCloud, we also implemented a MySQL consumer. And then our backend engineers can also leverage the entity relationship diagrams for their systems, not only for the Android code base. Something we want to explore in the future is writing a similar thing, a consumer for core data, so that our iOS engineers can also benefit from that. And then you have this kind of like cross-team pollination of tools, right? Like that it basically powers everyone together to be more productive. We make, environment agnostic tooling to create accessibility as well. So even though you don't want to use FloorPlan or you don't want to download the tooling within your local machine, we provide this like command line interface, and by leveraging basically other tools like Docker, we can also augment the power of FloorPlan and make it completely environment agnostic. That means you can run it on a CI box, you can run it on your local machine, you can remote control it through simply by using your terminal. And more interestingly and more importantly, that enables some inter-business department involvement. And that means, in other words, that basically means we make our code accessible for people who are not in the engineering department, right? So as I mentioned, security folks can look into it, but even like our PMs or designers can look into our documentation without even checking out the code. So that brings people together and makes it easier to collaborate within the feature teams by having kind of like a shared understanding of how things are organized and set up without actually needing to know how SQL works or how...
Sorry, Julio, you run out of time. We have to go on, please. Thank you. Yeah.
Okay, so just to finalize, here's the link for the tool. Actually, that was my last slide. So if you're interested, go to this tool, to the link and to the open source repo. I welcome your PRs. Sorry for taking over the time. Thank you. So here's my Twitter handle. If you have further questions, you can just ping me. I know we don't have time for questions now. I'm going to keep around to answer questions, but also you can find me on Twitter. And here you have also the link for applying for SoundCloud if you want to join the team and help develop FloorPlan and also other interesting tools. Thank you very much, and I'm sorry for taking over the entire time.